Good day, learners. I welcome you once again to COS 102 class, Problem Solving. This is study session 2. And under this session, we'll be looking at introduction to algorithm. We're going to look into how to break any problems into a precise, repeatable set of steps. These are the learning outcomes. I'll be explaining what algorithm is. We will discuss the characteristics and properties of algorithm, and also we are going to discuss how pseudocode and flowcharts can be used to represent algorithms. Now, you will already run algorithms every day without we thinking about it. Every morning, without thinking about it, we follow a fixed sequence of steps to reach a goal. Computer science just gives that idea a name and a much more precise set of rules. Today, we will look at what an algorithm is and what makes an algorithm a good algorithm, and also the two main ways programmers write them down before turning them into code. Now, this is an example of a morning algorithm. You wake up in the morning, you check your phone, you brush teeth, get dressed, and eat breakfast. These are sets of sequence of instructions that we follow every day. Computer science just give it a name and call it a set of rules, which is algorithms. What is an algorithm? Algorithm is a step-by-step method for solving a problem or completing a task. It takes some inputs, follows a fixed set of instructions, and produces an algorithm. So algorithm takes inputs, processes following a set of instructions, and also it produces outputs. Now, look at this. They are not computer programs, but all of them are algorithms. Starting a car, this is a recipe, driving directions. They are all sets of instructions that we follow sequentially to achieve a particular task. Now, this is an algorithm on how to start a car. You insert the key, make sure the transmission is in park, turn the key to the start position. If the engine starts within 6 seconds, release the key to the ignition position. If not, release the key and gas pedal. Wait 10 seconds and repeat steps 3 to 5, up to 5 times. So if the car still doesn't start, you call the mechanics. So this is an example of algorithm on how to start a car. Now, algorithm versus program. The algorithm is the logic of the solution. This is where the hard thinking happens and where most people get stuck. This is where the programmer had to sit down and design the logical solution for the problem. Now, the program code. The program code, the algorithm written in a programming language, usually the algorithm written in a programming language, this is usually the easier phase. The thinking is already done. That is, the thinking has been done already by you sitting down and writing the algorithm. You just translate it to programming code. So problem solving happens in 2 phases. You work out the algorithm and then translate it into code. There are 4 essential characteristics of algorithm. Number 1, algorithm should be exact. That is, every step must be precise with zero ambiguity. There shouldn't be any two-way about it. Every step must be clear enough to understand. And also, an algorithm, a very good algorithm, must be effective. It must produce the correct answer. Yes, that is, it must produce the correct answer to the original problem that has been given. Another characteristic is a good algorithm must terminate. It must finish in a finite number of steps. If an algorithm does not terminate, let's take for instance, if an algorithm enters an infinite loop, then it has not solved any problem, so it is not a good algorithm. And also, an algorithm should solve a general problem. It must work for every valid case, not just one example. Let's take for instance, if you have an algorithm to the one I gave you the other time, which is not a computer program, like if you have an algorithm to start a car, yes, such an algorithm should work for different types of car. Not that this algorithm will only work for a Toyota Camry, is not going to work for another type of car. Just to give you an example. So this is a classic problem. That is, this is the kind of problem the algorithm are built to solve. Like if you have an unlimited number and then how would you design an algorithm to make exact change using the fewest coins possible? Writing algorithm down, that is, we are going to look into this in two ways, using pseudocode and flowcharts. Now, pseudocode, this is a mix of plain English, math notation, and borrowed programming keywords. There is no single official format for pseudocode. It just needs to be clear. And then let's look at this example. The task is find the minimum, maximum, and average of a list of numbers. Now, the first statement is this: you initialize sum and count to 0, and then you initialize minimum and the maximum. This one only means running total and how many numbers entered. This one, that is the value, the initial value of the initial value of sum and count is 0, and this one is going to hold the smallest value. The max variable is going to hold the largest value. Now, for each number that is entered, then the increments begin to count. You understand? And then the sum also for each number that enters is going to be added to the value of the initial value of sum. And if the number that is entered is less than the minimum value, then the minimum value is the number. And again, if the number that is entered is greater than the maximum value, then that is the maximum value. And then after then, be able to calculate the average, which is the sum divided by count. That is the total number of the total number of the list of numbers. Now, the control structures, there are three main structures that is applicable to pseudocode and flowcharts: the sequence, the branch selection, and the loop, that is repetition. So the sequence, that is the steps executed one after the other. I told you algorithm are steps. There are sequence of steps that we follow to complete a task. Now, the branch, that's the binary decision. That is, here we make use of if-then logic. In every programming language, it is shown as diamond as a flowchart. We are still going to explain much better about flowcharts. And also, we have the loop representation, a step or steps repeated while condition holds. This is a bounded condition. That is, it continues as long as a condition holds. So these three combine together, including nested inside each other, that is to build every algorithm you will ever encounter. So all these three conditions, the control structures, are very much applicable. Now let's talk about flowcharts. A diagram built from standard shapes connected by arrows flowing from top to bottom, great for seeing a task logic at a glance. But for large programs, the algorithm can stretch across dozens of pages. So these are the symbols for flowcharts. This is the terminal symbol. We use it to start and end a program. This is the processing symbol, the rectangle, for processing instruction. And this is for input and output instruction. This is for decision points. And I have an example of a flowchart here. This is an algorithm to add two numbers together. You can see the terminal symbol that I used to start, the terminal symbol we used to end, and then the parallelogram symbol, that is for the input, for the output as well. And you can see the rectangle symbol for the processing. So in summary, an algorithm is a set of instructions that manipulates data to solve a problem. And also, an algorithm has four characteristics: it must be exact, it must be terminating, it must be effective, and it must be general. And also, there are two ways to represent algorithm: pseudocode and flowchart. Three control structures drive every algorithm: sequence, branch, and loop. A loop repeats a statement or sequence based on a loop condition. And also, branch, that is if then, explores one of two paths depending on a condition. So before I go, I have some questions here for you to think about. Number one, list 4 essential characteristics of algorithm. What is the advantage of using a flowchart to plan a task? So by the time I come back in the next section, I believe by then you will have been able to solve these questions together. So we have come to the end of today's session. See you in the next section.